right, so today we are going to review the next rule, kind of the last two rules of properties of exponents, so the two division properties of exponents. Pretty simple rules, I think. So the first one, dividing powers with the same base, which the first time that we talked about this, I kind of mentioned that when we multiply powers with the same base, we add the exponents. So it's kind of convenient that whenever we divide powers with the same base, we're going to subtract the exponents. But I think the idea is pretty simple, but I think how it gets tricky is whenever you throw in the negative exponents and then you have the coefficients and the numbers and all of those things. So let's say we have 6x to the fourth over 15x squared. So keep in mind that although division properties of exponents, we're subtracting the exponents, all those things, this is a division problem, it's a fraction. So when you look at the number 6 over 15, that's a fraction. So you want to make sure that fraction is in simplest form. If you ignore the x's, that's just 6 over 15. So if you were to reduce 6 over 15, you would be looking for a common factor. What do 6 and 15 have in common? 3, right? So, just like you know how to reduce fractions, divide each of those by 3 and you would get 2 over 5. Now with the variables, this is where we're subtracting. We have x to the fourth over x squared, okay? And remember, you would subtract 4 from 2, you'd get x squared. But the reason why is because if you have 4x in the numerator and 2 in the denominator, these can cancel out, these can cancel out, right? So 2 of them cancel out, but you're left with, right? Took 4, took 2 of them away, you're left with 2 of them. That's why we subtract. But you have to make sure that you put the power where the larger exponent was, because the 2 leftover x's are going to be up there in the numerator. So it would be 2x squared over 5. The other rule is also pretty simple. The product of it should be power of a quotient. Power of a quotient. Kind of like the power of a product. Everything inside the parentheses gets the power. So everything in the numerator gets the power, everything in the denominator gets the power. So if I have 4x squared over y, and that whole thing is cubed, just means you're going to cube everything. And you just have to make sure you do cube everything. You have to cube the 4. 4 cubed, 4 times 4 times 4 would give you 64. Now the rule from yesterday, when you take x squared cubed, you would multiply those together and get x to the 6th. And then don't forget about the denominator as well. When you cube the y, it would just give you y cubed. So those are the 2 new rules we're going to throw in today. All right? So let's get this glued into page 5, and this is 7.4 recap. All right, so number 1. Let's say we have 6x to the 4th over 12x to the 8th. Now remember, with the numbers, it's just a fraction. It's 6 over 12. Now I think this one always gets students because they're like, oh, 6 over 12 is 2. But it's not 2. Remember, we're dividing, not subtracting. Oh, okay, right, okay, sorry. Okay, we're dividing by 6. So you're kind of right if you're like, oh, it's 2, why is it not 2? Where's the 2 at? So when you divide out the 6, you do get 2. But where's the 2 at? It's in the denominator. So what I have a lot of students do is they'll say that it's 2. The answer is 2. 6 over 12. It's 2, but it's not 2, right? What is it? 1 half. See that? No. Okay, so you divide out of 6. 6 divided by 6, technically you get 1, right? 12 divided by 6, you get 2. See how the 2 is in the denominator? Okay, right. I just have a lot of students that will say when you do 6 over 12, you get 2. 2 and 1/2 not the same thing. Yeah? Okay. Maybe I made that too. Maybe guys weren't going to do that anyway. Okay. Now for the variables, we have x to the 4th over x to the 8th. Remember, when you have variables in the numerator and the denominator that have the same base, they're going to cancel out. So since I have 4 in the numerator and 8 in the denominator, 4 of these are going to cancel out. So those are all gone. 4 of these cancel out, which is why we subtract 8 minus the 4, give me an x to the 4th down in my denominator. Okay, number 2, x to the -3rd, y to the -2nd over x to the -5th, y to the 4th. Okay, for these ones, this is just a personal preference of mine. You can apply the division properties of exponents here. You could subtract the exponents, but I almost guarantee if you do that, you're probably going to get the answer wrong because you're not going to subtract directly because they're negatives. What I would do instead, before you think about subtracting or reducing a fraction by using the exponent rules, make the exponents positive. So, that x, that y, and that x all have negative exponents. So what I'm going to do first is move them. So this y to the 4th that I didn't circle, I'm not going to move it. It didn't have a negative exponent. But everything else needs flipped over the fraction bar. So the x cubed comes down to the denominator, the y squared comes down to the denominator, and the x to the 5th goes up to the numerator. This is a lot easier to think about because now I can see, okay, I have an x to the 5th in my numerator and an x cubed in my denominator. These are going to cancel out because they're on opposite sides of the fraction bar, right? When they cancel out, how many are left? 2, right? These 3 cancel out. 3 of those cancel out. So in your numerator, you have an x squared. Now in your denominator, say I have the y squared and the y to the 4th. They're just like right next to each other. These aren't going to cancel out because they're on the same side of the fraction bar. In your denominator, you have a y squared and a y to the 4th. How many y's do you have in your denominator? 6. 2 plus 4, so you have over y to the 6th. Okay, let's bring in that other rule that we've talked about. This is the one that I think starts getting tricky. So let's say we have 5x cubed over 4y to the -2nd, and then the whole thing is going to be squared. So kind of like the rule from yesterday, this means that I need to square everything in there, including the number. Don't forget about the numbers. You're going to take 5 squared, which is 25. You're going to take 4 squared, which is 16. Now, when you square the variables, x cubed squared, this is the rule where you multiply your exponents. 3 times 2 would give me x to the 6th. And in the denominator, -2 times 2 would give me y to the -4. And the last thing we'd want to do here, you wouldn't ever want to leave your answer with a negative exponent. And remember, the 16 and the y, they're not attached. They don't have to go together. The only thing you're going to move is the y. So the 25x to the 6th over 16, that stays, but the y moves up to the numerator. Okay, last one. And these are the ones that can start to get kind of tricky. Number 4. All right, in parentheses, 5x to the -4th, y to the -3rd, over 2x to the 7th, y to the -2nd, all to the -2nd. So kind of like we talked about yesterday, the slower you take this, the more work you show. I almost guarantee you the easier it is. So the first thing I need to do is I need to take everything to the -2nd power. Now, when I take 5 to the -2nd power, sometimes I'll go ahead and evaluate these, but I can't do 5 to the -2nd power because it has a negative exponent. So I'm just going to leave it as a -2nd power. Now, with the x's and the y's and these exponents here, you're going to multiply all of these by -2. So -4 times -2 would give me x to the 8th. -3 times -2 would give me y to the 6th. In the denominator, I'm going to take 2 to the negative second. And remember, I can't evaluate that. If you have a number raised to a negative exponent, you can't evaluate that, so just leave it for now. The x, 7 times negative 2 would give me x to the negative 14th. And the y is negative 2 times negative 2 would give me y to the 4th. Now next what I would do, let's fix these negative exponents. So we have the 5, the 2, and the x. Remember, if we didn't circle it, you're not going to move it. So the x to the 8th, the y to the 6th, the y to the 4th, those are all going to stay. The 5 moves down to the denominator. The 2 squared and the x to the 14th move up to the numerator. And then our last step here in simplifying. Now you can take 2 squared, which is 4. You can take 5 squared, which is 25. Now if you look at the x's, are the x's going to combine or cancel? Combine, because they're just right next to each other. So you have 14 of them, you have 8 of them. 14 plus 8 will give me x to the 22nd. Now will the y's combine or cancel? They cancel because they're on opposite sides of the fraction bar. So if we subtract, we should get a y squared. And remember, you're going to stick that power where the larger exponent was.